In this video, we'll solve this question under torque, and this question is under the equilibrium or the conditions under equilibrium. Question reads, a seesaw consists of a uniform body of mass 100 kg and length 4 support at rest. A farmer and daughter with a mass 80 kg and 40 kg respectively. The support is under the center of the gravity of the board. The father is distance x from the center, and the daughter is a distance 2.0 meter from the center. And the first question says, find the magnitude of the upward force and extended by the support on the board. So on that type of the question, what are you supposed to do? The first thing that you do in here is this. We are calculating the magnitude force, which is here. That's what we're calculating, right? The upward force. Now, if you look at the upward force here, it is supporting about how many forces that it is supporting? This upward force here. So this upward force here, it's supporting about how many force? 1, then 2, then 3. So it's supporting about 3 forces, because this one here, it's going up and all the forces are going what? Down. So I can say that is my normal force or my upward force. Now, the upward force, which is the normal force, is equal to 1, which is where the daughter has sat. According to the question here that I've even explained, and the daughter is a distance 2.0 from the center. So meaning that from the center here to where the daughter is sitting is what? 2.0. Now remember that that is the force there. So meaning that it will be m times g, that's a gravitation force, plus here on 2, which is m, which is of the Planck, times g, plus again the father, where the father is sitting. So in short, what is the mass of the daughter? The mass of the daughter, it's 40 times 9.81, plus what is the mass of the Planck? It is 100 times 9.81, plus what is the mass of the father? It is 80 times 9.81. Then what do you do next? I'll multiply. So it will be 40 times 9.81, which is the answer. It will be 392.4, plus when I multiply there 100 times 9.81, so there the answer to be 981, plus 80 times 9.81, so there the answer again, it will be 784.8. so meaning that when I add, right, so I have to add 392.4 plus 981 plus 784.8, then the answer, it comes to be 215.8.2 newtons. So that is the upward force. So that is how you calculate question A. Now, the other question now is, how do we calculate question B? Because we have answered question A, now let's calculate question what? B. So on question B, here are the things that you need to take note of. The first thing is that they are saying find where the father should sit to balance the system at rest. So in short, here what they're looking for is at what position should the father sit in order for this seesaw to be balanced, or for this seesaw to be at equilibrium. So in here we shall use what we call the equilibrium what condition. So the first equilibrium condition states that when the system is at rest, meaning that the summation of all the torque acting upon the system is equal to 0. So in short, here it will be the summation of the force, that the summation of the torque that is acting upon this seesaw is supposed to be equal to what? 0. And the other thing that you need to do is to remember the condition of torque. The torque clockwise is negative. The torque counterclockwise is positive. Now, let's look at where is our pivot. So this part, it's where the pivot is. So I have described that is where my pivot is. Okay. Now, where the daughter is sitting is this side. So I'll take this side as my torque 1, right? And I'll take this part here as my torque what? As my torque 2. So that's what I have done here. Now, after doing that, let's check out. So if this part here is my pivot, meaning that this daughter, her torque, it's moving in this direction. How about the father? Meaning the father, his torque, it's moving in this direction. So this simplifies that the torque of the daughter, it's moving counterclockwise. So if the torque of the daughter it's moving counterclockwise, which is my torque 1, it will be positive. So I'll say torque 1 is what? Positive. How about my torque 2, where the father is? So it's moving clockwise. The daughter was moving counterclockwise, which is positive, and the father is moving clockwise. So if the father is moving clockwise, meaning it will be what? Negative. So torque 2 it will be what? Negative, equal to 0. Then after doing that, remember what is torque? Torque is the force times the radius. So this is my 1 of the daughter minus 2 of the father, like that. Now what was the force of the daughter? So the force of the daughter, remember where we are coming from. The force of the daughter, it was this part here. So I'll say 392.4, like that. What is the distance? And the distance, it is from this part up to here. So meaning what's the distance where the daughter is sitting from the pivot? It is 2. So I'll say 2 there, minus. And what is the force of the father? The force of the father, it is this part here, which is what? 784.8. And what is the radius? The radius, it's the one which we are looking for. So I'll say it is what? X equal to 0. Then what will be the answer there? The answer, when I multiply 392 times 4.4 times 2, the answer to be 784.8 minus the other side will be 784.x equal to 0. Then you have negative 784.x or 0.8x equal to, the other one will come this side, so it will be 784.8. When it will be negative here. So meaning that I'll divide here so that I can find the value of what? X. So I have divided here again, even this side I have divided. So this means that my x is equal to 1. So for this seesaw to be balanced, the father should sit at 1. That's when the seesaw it will be balanced. So guys, make sure you subscribe to the channel and also comment and also like. Thank you.